All right, welcome to 2014 and back to AP Chem radio, or video, sorry. Okay, this is the easiest notes you're ever going to do. It's on the pH scale. I know that most of you learned this last year, but we're going to review a few things. So, obviously pH is a way to represent whether something's acidic or basic. Really, pH is actually numerically expressing the amount, the concentration of H plus in a solution. So, of course, low pHs mean acidic. 7 means neutral, and pHs above 7 to 14 are basic. Okay, so we knew that. All right, now, what is pH? You might remember this formula from last year, that pH is the negative log of the H plus ion concentration, or it's a negative log of the hydronium ion concentration. Either way, it's the exact same thing. All right, make sure that you guys pause and write this stuff down, okay? Now, the big thing that I want you to remember right now is that really pH is an exponent. Okay, so when you actually take the negative log of something, it's just the exponent. So a way of rearranging this is to say, okay, if I want the H plus or the hydronium ion concentration, it's really, that's equals 10 raised to what power? Well, that's what the pH is. The only difference is you kind of work in that negative. Okay, so whatever your pH is, it's just the exponent that 10 is raised to get that H plus. Okay, and it just makes our numbers a little bit more convenient, as we're going to see. All right, so let's take a look at this little graph. Not a graph, little table. Okay, so these are some hydronium or H plus ion concentrations. So 1.0 times 10 to the negative second. Okay, so if I actually take that out of scientific notation, move the decimal place over 2 spots, it's 0.01. Okay, well, what exponent is making that number happen? The pH for this solution would be a pH of 2, because 10 raised to the second power is pH 2. Okay, and of course we had that negative in there because it's a decimal, and that's fine. Okay, we just dropped that, so that's why it's negative log. Okay, so what if my H plus concentration was 1.0 times 10 to the negative third? So this is what it would look like if I actually wrote it out as a decimal. Okay, so 10 to what power produces this number? Well, that number would be negative 3, so take the opposite sign, it would be 3. So this would be a pH of 3. All right, between these two solutions, which one's more acidic? Well, acidity is based on how much H plus you have. An H plus of 0.01 is more H plus than a pH of 0.001. And you guys knew that a pH of 2 is a more acidic solution than a pH of 3. Okay? So what about this one? 10 to the negative 7th. Okay, so what exponent is making that happen? Take the opposite sign. It's just 7. Okay, and likewise, the pH of this solution would be a pH of 9. Now, pH of 9, you guys know, is above 7, so this would be a basic solution. Well, is this very much H plus? Not at all. 10 to the negative 9th is a very low concentration. That means if your H plus is low, then what must be high? Your minus must be high. Okay? So that would be a basic solution. So if your H plus is low, then your OH minus is high. So that's what's going on there. All right, so 4, okay, what if the H plus concentration is 3.5 times 10 to the negative second? Well, 2 is not the answer, because this would be the H hydronium ion concentration with a pH of 2. So this one, you have no choice. You have to plug it in. So pH equals the negative log, and you plug that H plus concentration in. And what does the answer come out to be? 1.46. Okay? Now, just thinking about the test you're going to take. You can't use a calculator. So sometimes you got to be able to understand pH without being able to punch it in. So pH of minus 2. So that would, an exponent of minus 2. That would be a pH of 2, right? Well, 3.5 times 10 to the negative 2 is a bigger number than 1.0 times 10 to the negative 2, right? Between this one and this one, which one's more acidic? This one is more acidic. So it has to have a more acidic pH. So it kind of makes sense that the pH is 1.46, which is more acidic than a pH of 2. Does that make sense? It's something you got to think about when you have like multiple choice and you can't use a calculator. All right, so go ahead and punch this one in. All right, pH equals negative log of 6.8 times 10 to the negative 8th. The answer for this one comes out to 7.17. Again, this number is a more acidic solution than if it was 1.0 times 10 to the negative 8th. So you know what? You knew it had to be more acidic than a pH of 8. So 7.17 makes sense. All right, hope you guys remember that. Okay, big take-home message here. Note, a change in H plus by a factor of 10. So going from 0.01 to 0.001, that's a factor of 10, causes a pH to change by 1 pH unit. Okay? So a better way to understand it, if I go from a pH of 2, or sorry, if I go to a pH of 3 to a pH of 2, I'm becoming more acidic. This number here is 10 times more acidic than this number. Okay? So if you change by a factor of 1 pH unit, it's going to be a times 10 change in hydronium ion concentration. All right. Again, that helps with multiple choice questions where you can't use a calculator. Okay, so what's this all mean? So if the H plus ion concentration is 10 to the negative 7th, okay, that's a pH 7. We knew that that was neutral, okay? Well, water does ionize, okay, a very, very tiny bit. So water does break up into H plus and OH minus. So if the H plus is 1.0 times 10 to the negative 7th, then what's the OH minus? Well, these are in a 1-to-1 ratio, so the OH minus would also have to be 1.0 times 10 to the negative 7th. My pen does not work very well. I apologize for that. That being said, you can have a pH, that's fine. Well, gosh, couldn't you look at a solution in terms of OH minus as well? Well, that would be called the POH. So pH is for hydronium, POH is for hydroxide. Same formula, negative log, but instead of H plus, we'd be looking at the hydroxide. Okay, so that's just brackets. All right, so you guys knew that. So if you can take the pH of a solution, you can take the POH of a solution based on hydroxide instead of H plus. All right, so then there's a relationship between pH and POH. It's very simple. pH plus POH has to equal 14. Okay, you're going to use that a lot. Just a little FYI, why does this work? I'll show you guys real quick. You guys remember the KW expression? KW equals H plus times OH minus. Well, what if you just took the negative log of everything? So if you took the negative log of the H plus, and then you took the negative log of the OH minus, well, whatever I do to this side, I'm going to do to this side. So if I took the negative log of the KW, 1.0 times 10 to the negative 14th, then it would simplify to produce this simple formula. This would simplify to pH, this would simplify to POH, and negative log of 1.0 times 10 to the negative 14th, of course, it's just the exponent. With the opposite sign, it would be 14. Just so you guys see how that comes about. All right, so now that you got all your formulas, here's a question for you. The pH of normal rainwater is about 5.5. Okay, that's not particularly acidic. It does have a little CO2 in it, which does make it somewhat acidic. What if you have a rainfall sample that's pH of 3.5? More acidic, right? By how many times more acidic is a pH of 3.5 to 5.5? So we know that there's more hydronium ion concentration here, but by how much? So you should pause this and think about it. I'll give you some choices though. Do you think the hydronium would be, let's see, 20 times more? Or 100 times more? Those are usually the two common answers. Which one do you guys think is right? So hopefully you did some thinking about it and came to this conclusion. That if pH is 3.5, it has 100 times more hydronium than a pH of 5.5. Keep in mind, every time you change one pH unit, that's a times 10 change in hydronium. So 3.5 to 4.5 would be 10 times more acidic. 4.5 to 5.5 would be another 10 times. Okay, so the pH 3.5 would be 100 times more H plus than a pH 5.5. I want to show you guys that you can prove that mathematically. So if my pH is 3.5, how do you go backwards and take the pH and turn it into hydronium? What I want you guys to remember is, again, that pH is an exponent. Okay, so if you want the hydronium, so again, if you want the H plus, 10 to the pH with the opposite sign is going to give you that hydronium. Okay, so you just got to remember the sign, and just remember pH is the exponent that 10 has to be raised to give you that H plus. So literally, you should punch this into your calculator. 10, 10, raised, that little caret guy, to the negative 3.5. And you type it in and you get this answer. Okay? Same thing with the 5.5, and notice that these numbers are related, that this guy here is 100 times greater than this guy. Okay, and if you didn't know that, you can punch it into your calculator to prove it. All right, what else we got here? Well, you guys got all these formulas. These formulas would always be given to you, and I want you guys to complete the examples on the back. I just want to take a look at these first two for a second, because there's something about sig figs. Let's see if you guys are paying attention. All right, minor detail, but I want to throw it out there. This is how it works, okay? How many sig figs in 2.51 times 10 to the negative fifth? 3 sig figs, right? What that means is that when you take the negative log of it and you get the pH, that it should have 1, 2, 3 past the decimal place. So in other words, this 4 does not count for sig figs. Okay, it's really just the exponent piece. Exponents aren't measurements, right? The numbers past the decimal place are what counts for sig figs. So if this has 3 sig figs, this goes to 3 places past the decimal point. Okay, this guy here, 6.3, has 2 sig figs. So 5.20, meaning 1 sig fig, 2 sig figs. So you're going to have to get used to that. It's not a big deal, but it's just something you want to pay attention to. All right, so I did these for you. I want you guys to do the rest. For letter C and D, though, I want you guys to notice that I gave you the hydroxide. Okay, that's fine. Hydroxide, but if you want the pH, then somehow you got to do some extra math there, okay? If you take the negative log of this number, that won't be pH, that'd be POH. And then, of course, can you use this formula here to go from POH to pH? Okay, so it looks something like this. The negative log of that number, that's the POH. Notice I did take into account the sig figs. And then when you subtract it, that's the pH. Okay, and of course 14 is 14.00000, like infinite sig figs. Okay? I'd like you to do letter D, and then I'd like you guys to do this cute table. Okay? And I guess you guys saw the answers, so do them, and then pause, and then go back and check your work. So I'll put it back up here. Of course, you should have done the work yourself. If you're just copying the answers in, you are totally wasting your time. Right? Okay. From there, a couple more questions. I just want to remind you guys about this one, that if you have pH, how do you go back to H+? Just remember that the pH, that number is the exponent. So 10 raised to the negative 4.5. Okay, it gives you, in terms of sig figs, okay, so 4.5, that's a pH. Remember, the 4 does not count for sig figs, so really, that's 1 sig fig. So when you round this guy, it comes out to, I guess, maybe what, 3 times 10 to the negative fifth. Okay, wanted to do letter B, please. Okay, the pH is 8.95. Do it. Okay. Once you got an answer, we'll check your work. Comes out to 1.1 times 10 to the negative 9th. Okay? Last but not least, this last problem, I'd like you to think about it. Okay, and go ahead and bring in an answer for this when you come in tomorrow. Okay? All right, thanks for listening. I appreciate it, and have a wonderful day here in Comic Country. Stalling, can't find. Oh, there it is. Bye-bye. Bye.